Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Malia Science.
Hey, Dad, I lost a tooth.
Whoa, yes you did. Wow, that is a big baby tooth.
Well,
That's a big tooth there.
look at this. This is a big tooth.
Oh,
Compared to that,
well, yeah, you're right. Okay, this megalodon tooth is way bigger than your baby tooth. So that gives me an idea. I think we're going to do a little bit different video this time. There's a really neat science program out there called Scale of the Universe. Let's take the kids on a walk through this program. Let's show them how to find it, and let's explore it with them. And then when we're done, they can explore it on their own with their parents. This will be awesome.
yeah.
Let's go. First, how to find it. Okay, so here we are. This is a program called Loom, and I'm going to use it to show you how to find a really cool website that helps us explore the size of different things. And when we think of big and small, we have to think of a scale. So, like your dad might be big, but compared to a mountain, he's small. But compared to an ant, you're huge. So this is a really cool program. And I started off on Google just so you could see how to find it. Type in, scale of the universe 2. Spelled it, but it's spelling it right for me. Scale of the Universe 2, Science Links Net, awesome. And launch tool. Okay, then we just hit start, and here we are. Really neat. Let me back up a little bit. Whoa. It's fun to do really fast and on a big screen if you can. So here we are looking at the relative size of things. And we start off with an average human. Okay, and you can click on him and say, well, an average human is 1.7 meters. So that's a little less than 6 feet tall. So, a few inches less than 6 feet tall. And there are 7 billion of us. I'm going to assume you're a human. I am a human too. Did you know that there's over 7 billion of us? That's a lot. In fact, if you met each person for 1 second, it would take you about 200 years to meet all of them. Better get started now. So we're not going to click on every single thing. But we have to decide if we want to get small or big first. Well, let's get small. There's the giant earthworm. 3 meters. Whoa. That's over 9 feet tall. So, yeah, meters are a metric unit, where most of us use the standard form. Dodo bird, which is extinct. How big are they? Boom. 1 meter. And push. Approximate size of a TV or of a computer screen. Smaller. Mouse. Oh, Russell's teapot. That's an imaginary teapot. It's just somebody said that there's a teapot in outer space between Earth and Mars, and it was just flying around out there. And he did it to say, okay, I say it's there. You can't prove me wrong, so I must be right. It's kind of silly. Not really good science. Then we get a hummingbird, a matchstick, a chicken egg, an earthworm, a quail egg, a microwave length. This is how long microwaves are. The size of a penny. A glass marble. Oh, we're getting tiny. 1 square inch, which means if it was 1 inch by 1 inch by 1 inch by 1 inch. A sunflower seed. We know those. Sleet. Ant. A grain of rice. Oh, we're small. We're tiny. But look how much smaller we have to go. We got to go all the way over to the end to get the smallest we can be. duckweed. It's that little green seeds that stick to us sometimes outside. A grain of salt. The largest bacteria is about the same size as a grain of salt. Dust mite. Amoeba. Paramecium. Human egg. Human hair. Thickness of paper. Silt particle. Smallest object visible to the human eye. So all these things smaller than this are not going to be visible to the human eye. You need a microscope, or at very least a hand lens. Width of a silk fiber. Mist droplet. We can see droplets because we can see a bunch of them together. A twip. What's a twip? A twip is a 12th of a typographical point. That means 12-point font. Oh, okay. It's for like printers and things. You learn everything new. Something new every day. I did not know what a twip was. A white blood cell. Ooh, wow. Red blood cell. These are the guys that fight off bacteria and infections in your body. When you're sick, you get a lot of white blood cells. They give you runny noses and a fever, but that just means they're working. They're your soldiers. And the red blood cells, these are the guys that carry your oxygen and nutrients to all the cells in the body. Whoa, we are getting so small. I feel like Miss Frizzle. If you don't know who she is, look her up. Chromosomes, that's what makes you you. E. coli, bacteria. Violet light wavelength. Oh, remember we talked about lights, they travel in different length. Well, that's violet. The largest virus. Bacteriophage. Type of bacteria. Wow. I think they look like robots. Yeah, not life forms, but they are living things, but they do. They look like robots. Smallest thing visible to an optical microscope. So that's a microscope that you might look through with your eye, whereas the other times would be like electron microscopes. There's another virus, some more viruses, a transistor gate. Whoa, that's part of computers. These get smaller and smaller every year. And I don't know if it's a true story, but I think I have heard this, that some lady scientist was trying to invent some part of a computer, and it blew up. It broke up, and she realized that every little piece that blew up worked. So she made these little tiny transistor gates. I don't know if that's true or not, but something like that. There is a lot of things in science that happen in accidents. DNA, that's what makes you, you. So it makes you share some of that from your mom and some from your dad. And that's why you might look like your mom or your dad, or a little bit of both. Or grandpa or grandma. X-wavelength. X-ray wavelength, I'm sorry. That's the wavelengths that, from one of our last videos, there's your water molecule. There we have hydrogens, 2 hydrogens, and 1 giant oxygen. And we have the smallest thing visible to an electron microscope. Whoa. What's smaller? Gamma ray. Oh boy, I think I've heard those in Incredible Hulk, but those are real things. And a lot of these are just different sizes. Uranium nucleus. We harvest those we try and harvest their power for nuclear energy. Chlorine nucleus. The center. Oh, wow. An electron. Whoa, we talked about these. Well, these are the little parts that move along wires to make electricity. They also jump from the clouds to make like lightning. Helium nucleus. Proton, neutron. Whoa. Wait a minute. I really thought the electron was smaller than the protons and the neutrons. Okay, so, we're going to go shorter real quick, but it says lengths shorter than this are not confirmed, which means we really don't know how. But I'm going to go to the shortest real quick. Quarks. This is all part of a really strange word called quantum physics. And it's just how we don't know why some things happen in science. And so we just come up with theories. Up quarks, down quarks, charm quarks, bottom quarks, top quarks, neutrinos. And let's go to the very bottom. Oh my gosh, we're getting so small. Here's the smallest. It is a quantum foam and string. Wait a minute, string? No, I know there's string, and I've seen string. I've flown I've flown a kite, and I have definitely seen string, and it's pretty big. It should be way up there. Well, that's a different type of string. That comes from something called the string theory, which means, let's see, according to the string theory, strings are one-dimensional. What? Means they can travel to different dimensions, but vibrate in other dimensions. The strings, however, is not the same string that you use for flying kites. Oh, whew. This string is between 10 to the 32nd power. It's way, that string is way larger than this string. Way larger. So again, these are all just parts of theories. Now, all right, we need to grow. We need to grow. Let's move me out of here so we can grow. Ready? Grow. We're growing. Oh boy. And now we're the size of a human hair. And now we're the size of a human. Whew. That was pretty fun. Now we're going to get bigger. All right, you ready to grow? And see what's bigger. All right, let's see. We know lots of these things. Ooh, Japanese spider crab. Ooh, they're bigger than a human, but smaller than an elephant. A giraffe, a Tyrannosaurus Rex, an oak tree, a Boeing 747. These are big. The Titanic, the Hoover Dam, Half Dome, big building, the Vatican City. Uluru, which is also known as Ayers Rock, is a rock at 348 meters tall. It is shorter than many buildings. However, it is 3 kilometers in length, making it longer than all buildings. No, how about that? I think is that a moon? Yes. Oh, it's known as Earth's second moon. It actually isn't Earth's moon. It just follows an elliptical orbit around the sun that is near Earth's orbit and is 364 days close to Earth's year. So a moon is something that orbits, or a satellite that orbits a planet. And we have one moon, and that guy just kind of follows along. So we call him our second moon. Kind of like when a stray cat shows up and you say, oh, that's our cat, but it's not really. Oh, this is an island, but it's the biggest man-made island. Mount Everest. Marathon, 26 miles, a neutron star. Wow, that's pretty small actually for a star. Remember, there's a lot of stars in our universe, and our star seems big because it's close, but the neutron star, our star is actually just a medium-sized star. This is a very tiny, tiny star. Rhode Island. A lot of these are moons, probably moons of Jupiter, or wait, no. Is Iris's only moon and was discovered on September 20th, 2005. I don't even know where Iris is, but it must go around something called Iris. Hydra is one of Pluto's moons. Okay. There's another moon of Pluto. Oh, Pluto's not even a planet anymore, and he still has moons. Rwanda, the Grand Canyon, West Virginia, Italy, Ceres. Oh, okay, here we go. Pluto. Oh, there we go. Iris. What is this? The largest dwarf planet. Okay. It is even bigger than Pluto. Wow. I never even heard of that. There's another planet in our solar system. It's a dwarf planet, but it's the largest dwarf planet. And we never even heard of them. Iris. Iris is also very far from the sun. Iris has a moon. Oh, we just saw that. It's directly beneath the period at the end of this last sentence. Okay. All right. So here's the United States. So all of these moons of different places, some of these are smaller than the United States. And a lot of them are smaller than Asia. And we got some other smaller planets here. Mercury, that's the very fast planet. Venus, Titan, Eurasia, and there we go, Earth. Sirius B, another star. Cool. I really like this program. Uranus, Neptune, Saturn. Minecraft World. What? So, Minecraft World, if you walked across Minecraft World, you would eventually get to the end of it. It would run out of data. It's programmed in different lengths. But it would take you about as long as it would to walk across Neptune, which is a much bigger planet than Earth. So longer, way longer than walking across the whole Earth. So I wouldn't try it. It would take forever and ever and ever. Well, it would take a long time, not forever. Saturn, Jupiter. I want to find a different moon. Well, let me see if they have it here. Let me get Europa. Oh, yeah. So Europa is a cool moon. It is covered in ice, and there's mysterious streaks that cover the moon's surface. Some people believe that water might exist beneath the layer of ice, possibly even holding life. That means scientists think if there's any other life in our solar system, it is on this moon. So it would be, and we'd have to dig through the ice and search the water underneath it, if there is water underneath it. But we'd have to get there before we could do that. All right. Whoops. Europa. Cool. Now let's go back up. Minecraft World. Oh, now we're getting into some big stars here. Sirius A, Sirius, Polaris, the North Star. All these are different stars. Ooh, the Kuiper Belt. Oh my. And this is light of day. We're so big, this is how far light would travel in one day, right? It takes just like, around 5 minutes for light to get all the way from the sun to our Earth. So in a whole day, it would travel this distance. That's pretty big, right? And here we have distance, Voyager 1 to the Earth. So how far that's going. Now, this is a nebula. Now, do you ever wonder where stars came from? These nebulas are the places where stars and things are formed. It's pretty cool. At the center of the Homunculus Nebula lies a star. The star, which is Eta Canaris, had a magnitude of blah, 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 blah. Wow. Some of the things we see in the sky are nebulas. They are nebulas. Distance? I don't know what that is. Oh, here's another nebula. And when you find a nebula, you get to name it. And a lot of people name it by what it looks like. Stingray Nebula. Somebody thought that looked like a stingray, one of those sea creatures. Oh boy, what do you think they called this guy? Right there. A scientist named Gomez found it, and he called it Gomez's hamburger. I think I would have called it Gomez's hot dog, wouldn't you? But Hourglass Nebula, that one makes sense. Cat's Eye Nebula. Now we're up to how far light travels in a year. Cool. The Ant Nebula. I can kind of see an ant. Eskimo Nebula, no clue. Bubble Nebula. Oh, the Horsehead Nebula. Yeah. If you look at the real picture, you can see it looks a little bit more like horseheads. Boomerang Nebula. The Bubble Nebula. Cone Nebula. Crab Nebula. I don't see a crab, but Pillars of Creation. Great Nebula. North American Nebula. Eagles Nebula. Oh, that's cool. Google a picture of the Eagle's Head Nebula, and it looks like somebody painted a really cool picture. It's really awesome. You wouldn't believe it's actually a nebula. You'd think it was a painting. All right, now we have star clusters, just a group of stars together. Wow, we are getting big. Galaxies. Wow, we live in the Milky Way galaxy. But there's a bunch of other galaxies out there too. Pinwheel Galaxy, Andromeda Galaxy, Tadpole Galaxy. Distance Earth has traveled relative to the Sun. Local group. We'd have to read about these. Iodometer, distance of the Great Attractor, gigaparsec, Sloan's Great Wall, observable universe. Whoa, wait a minute. We lost it. Observable universe means things that we can see with our telescopes or things that light has reached us from. But how big is the actual universe? We don't know. It's huge. All right, one last thing. Let's take a shrinking visit all the way back down. Oh, we're shrinking. Oh no. Whoop. We're the size of that tiny string. And now let's grow. We're growing up to the size of the universe. And you know what? It's time to go back to human size. All right. Okay. And there we are. Back at human size. That's a pretty cool program. You should get on it and check it out. And it's really fun to play with. All right, guys. So that was a little different video, but I really wanted to share this program with you. So we'll see you next time. Bye-bye.
Let's open our eyes to the world that's around us. Science has the answers to the questions that have found us.
Malia Science.
Science.